Uh, so I'm holding you back from being free and go home or party, so sorry about that. And since I'm the last, I agreed with Patrick that I can run over because I might have more to say than I originally planned. So it might take a bit longer than 25 minutes. So my name is Csaba. I go by the Evil Bit on Twitter, X. Uh, it comes from RFC. I mean, my handle comes from RFC 3514. If anyone knows that, that's an April Fool's joke. There is a bit in the IPv4 header, and it was proposed that if the packet is malicious, it should be set to 1. And if it's not, then 0, and all your firewall filtering is solved. So that's the evil bit. So launch constraints. Did anyone heard about launch constraints? A few hands, okay. And bananas. So I heard you like bananas, so we have bananas in this talk. So before I start with launch constraints, a few words about myself. I'm currently working for OffSec, doing the Advanced macOS Control Bypasses training, which is basically a macOS exploitation course. I used to be a red and blue teamer before in a big oil company, and we actually used the attack framework, what Kat talked about, before it was cool already. So I'm a big fan of that framework, so if you don't use it, start using it. I do macOS bug hunting in my free time. I'm mostly focused on platform-specific stuff, especially TCC. I'm married, have 2 kids, and I'm really into trail running and hiking. So, but before we jump into launch constraints, do you know which country is Europe's largest banana producer? Yes, it's Iceland, because it's warmer. So they actually grew bananas in like these warm glass houses and heat it with geothermic. Technically it's Spain, but because all their banana plants are on Canary Islands, and Canary Islands belong to Africa, it's not Europe's largest. Anyway, so before launch constraints, I will talk about some old macOS vulnerabilities that actually paved the path for Apple to do and engineer launch constraints, which was introduced in Ventura. This will be a praise part of the talk for Apple, and then I will talk about old and current third-party vulnerabilities, and then the new launch and environment constraints, which Apple introduced in macOS Sonoma, and this will be more like a shame part of the talk. So, some old macOS vulnerabilities. TCC bypass with the image and app. This was found by Adam Chester, goes by XPN. So this application had some really nice TCC and keychain entitlements that you can see on the right. So for TCC, it had permission to access your contact details, so it could access the contacts without showing any pop-up to the user that, hey, Imagent wants to access your contact, do you allow or not? It's a private Apple entitlement, so it just used that and could access the contacts and some part of the keychain. So what Adam found is that this application can load plugins from the contents plugins directory of its own bundle, and that its code signing allows third-party plugins. But the issue was that this application resides on the system partition, so you cannot just write there. But there is nothing preventing you from copying that application out, maybe to the temp directory, create a plugin, start the app, and boom, you access the contacts and bypass TCC and some part of the keychain. Another TCC bypass using directory utility. This one had a CVE number. This one was found by Wojciech Regula. Basically, the directory utility has another interesting TCC entitlement, which allows it to modify admin-related configuration on the system, which includes user properties, which includes the user's home directory. So if I can change the user's home directory, I can plant a new TCC database because it's one of the databases sits in the user's home directory. I can create a new database, redirect the user home directory, restart TCC, and load my custom rules. So I basically almost entirely bypassed okay. So I almost entirely bypassed TCC because I can implement. Is it? Okay. Any custom rules. So I can give any permission I want to any of my malicious applications. The way this was exploited, directory utility supported plugins. So he made a copy of directory utility, loaded the plugin, and boom, done. Another TCC bypass. I told you I'm a big fan of TCC. So config.d, this exploit was named PowerDeer. It was found by Jonathan Barr from Microsoft. Config.d had the very same TCC private entitlement that allowed it to change admin-related stuff on the system. And while config.d normally runs as a system service, there is nothing preventing you to run it from the command line with the -b option, which allows you to load a bundle, any bundle. So you just run config.d -b, load your bundle, you run inside the process, done. Easy peasy, really. So Apple said it's enough, and they engineered launch constraints. So what is that? It was introduced in macOS Ventura, and it basically mitigates many of the previous and other logic vulnerabilities on the system. So the vulnerability might be there, but they make exploitation impossible. Launch constraints, there are 3 different constraints. There is a self constraint, which applies to the binary, the process itself. There is a parent constraint, which applies to the parent process of the process. And there is a responsible constraint, which applies to the process which is responsible for launching the other process. So imagine an XPC service. XPC is an IPC mechanism. Let's say you have a global privilege helper tool, which is offering some service over XPC. You want to connect to that service. It's not run by default. So your client will talk to LaunchD that, hey, I want to talk to this service. LaunchD will start the XPC service, and then you can communicate with that. Now, in this case, the parent process of the XPC service is LaunchD, because LaunchD is responsible for starting it. But the responsible process is your client, because you wanted to talk to that process, to the XPC service, so you are responsible for being started at all. So how launch constraints look in action? Let's say I copy any of the applications, or any binary, in this case, the find my app, to the temp directory. I try to start it, and it will crash. And I get an error, which doesn't say too much. But if I monitor the mfee logs, then it will say there is a launch constraint violation. So that takes us to launch constraint categories. So we violated the constraint, but we don't know what it is yet. A launch constraint category basically defines a set of constraints. In Ventura, Apple had 7 of them. In Sonoma, there are 18 of them. And they assign each binary into one of the categories. This assignment can be found in the trust cache, which I will talk about later. So let's see how a launch constraint category looks like. So this is category number 1. It's the same across Ventura and Sonoma. So like the 7 was extended to 18. So category 1 is the same on both. So category 1 has a self constraint and a parent constraint. So the self constraint says that the binary must reside, it says, on authorized out APFS volume or on a system volume. This means that the binary must reside either on the system volume, like /system, or an authorized APFS volume, which I guess are the cryptexes, really where they store all the dilib cache and all the stuff that can be updated through the RSR, the rapid security response. So the binary has to be there. Then it says launch type 1, which means that it must be a system service, so it must have an associated launch daemon or agent file under system library launch daemons or agent. And validation category 1, it means that it must present in the trust cache. Now there is also a parent constraint which says is init pros, which means launchd. So any binary that is assigned to this category means that it must be started by launchd, and it must reside on basically on a protected volume, and it must be a system service. Now, if we check which binaries are assigned to this category, we will find most of the system services daemons, for example, these ones. This is just a small subset of the whole list. If we look on another category, like 2, it's much less restrictive. It only says that the binary must reside on like a protected volume, basically. So it's either the system or the cryptexes, which is basically you find all your command line tools. So it means that if you copy, let's say, the ls binary out of its place to the temp, it will not run. Simple as this. So Apple now has like 18 of these categories, and each binary in the trust cache is assigned to one of these. What is a trust cache? This comes from the iOS world. So basically, a trust cache is a list of all the CD hashes of all the system binaries found on the system. And if you are an Apple-signed binary, you are only allowed to run on macOS, on Apple Silicon, if you are inside this trust cache. So if I'm running Sonoma now, if I take any Apple-signed binary from macOS Ventura and try to start it, it will not run. So this is actually pretty cool, because this is not the case on Intel. This on itself mitigates all the downgrade attacks that we could do on Intel devices. Because on Intel devices, I could take a 3-year-old macOS application, which might have been vulnerable to something, and I can just run it because it's signed by Apple, it has the entitlements, it has everything. It will be accepted by the system. It's old but not obsolete. So the trust cache can be found on a couple of places. It's basically it's an image4 file with image4 payloads. Inside, we can use the py-image4 Python utility to extract all the data we want, and then we can use the trust cache utility to actually analyze it. The Trust Cache version 2 has a new entry in the structure to allow for the constraint category. So if we run this tool, then the fourth column will contain the actual category for the hashes. So how we can reverse launch constraints? Launch constraints can be found in Apple Mobile File Integrity kernel extension. They are defined there. You can either extract it from the kernel cache, but I think it's easier to download the kernel development kit, install it, and you get the MFI from there. You will find all these symbols starting with constraint category, and you get the number, and if it's a self or parent constraint, and this is what you get. So this is all the stuff dumped out. So how we can translate this to actually something human readable? So it turns out that, and Linus has documented this, that this is an ASN1 there encoded data. So it's an ASN1 serialized format. There are many tools to decode it, like Python ASN1. Their encoding is basically a type length value encoding. So I have a quick sample of this here. So this is one of the constraints, and on the right we have the interpretation of this. First we have a type, which is sequence, then we have a size, 75, that's the size, and then we have the data. So basically the first sequence is the whole stuff. Then we have an integer, it's 2, size 1, value 1. Then you have another sequence, and then inside the sequence another sequence. Then you have a string, and then another sequence, inside another sequence. Then you have a string. Again, this is the unauthorized APFS volume. Then we have a Boolean, and basically so on. There are tools to do this. But basically, this is how DR encoding or decoding works. And this will basically become unauthorized APFS volume or on system volume and launch type 1 and validation category 1. So how does it mitigate attacks? Image and tab and directory utility, they have to reside on either the system volume or the APFS volume. So if you copy them out, they will not run. You cannot inject plugins. Config.d, again, it has to run as a system service, must be started by launchd, so you cannot just run it from the command line. So I think this is one of the best security features Apple introduced in Ventura for mitigating local attacks, and I think it's some great engineering effort and solution to those problems. So huge kudos for them for this. Now, some typical third-party attacks. XPC. It was a big thing a couple of years ago, and it's less of a thing nowadays, but it's still, I still see XPC exploit every couple of weeks. Both Wojciech Regula and me did presentation blog posts about these attacks, how to do it securely. The problem with third-party XPC services is usually you have a root component, like a privileged helper tool, which runs as root. Now, normally anyone can connect to that in the system, and if anyone can call those functionality that is offered by the service, someone can abuse it and escalate their privileges to root from any user, really. So your XPC service must ensure that only your real client can connect to it. Now, there is a big problem. Client validation is not hard, but not straightforward. Also, Apple never released the documentation how to do it securely. they released one documentation where they say it's secure, but it's not. It's called even better authorization example. If you see that, don't use it because it's not secure. Also, when you do client validation, you must use the audit token of the connecting process. Now, until Big Sur, well, even nowadays, the audit token APIs are private. So by default, if you just wanted to use public APIs, you couldn't write a secure XPC service. Thank you, Apple. As of Big Sur and Monterey, they introduced 2 new APIs for XPC, which use audit token behind the scenes. So those should be fine. But again, there is no documentation. Client must be signed by a developer certificate issued by Apple. Client version must be checked. This is for downgrade attacks to avoid that I can just inject a code to an old client. Or we should verify that the client doesn't possess dangerous entitlements. Now, that was XPC. It's still a thing. Electron framework. Anyone here codes Electron applications? I apologize in advance. I hate them. And not just me, like most of the security people, because we think they are not healthy from a security point of view. Electron is basically a framework which allows you to develop web-based application for multiple platforms. There are some small tools like Chrome, Signal, Slack, Discord, Microsoft Teams that basically developed on top of Electron. They often have very nice TCC permissions, like access your camera, access your microphone, because they are usually like AV tools as well. But they are subject to injection attacks. I talked to the Electron guys, and they said, local attacks are not in their threat model. Okay. That means that you can set the Electron run as node environment variable to 1, and then your application will start in an interactive shell. And basically, you can run anything inside the tab. Now, this can be now disabled. You can run these applications with the inspect or remove debugging port arguments, which allows anyone running on the system to attach a debugger and, again, impersonate that application. You can turn off inspect, but you cannot disable remove debugging port. So you can start any of these applications with remove debugging enabled and potentially inject your code and bypass TCC. DILIB injection, I think that's less of an issue nowadays, unless you need to support external plugins. You have to use the COM-Apple Security CS disable library validation entitlement so that you can load third-party plugins, which means attackers can also load their own stuff, which is not good. So it opens up the attacks for more XPC and TCC bypasses. Now, launch and environment constraints for third parties. This came in Sonoma. So when I applied for this conference, I sent this abstract to Patrick, and I said, okay, at the end, I will talk about how you can make secure third-party apps. I sent this. I researched 80% of the talk, except this. I left for a 3 months vacation. I came back in September and started to dig into this. And I will rant about how Apple failed big times here. Because I think why launch constraints solve their problem, it doesn't solve the problem with the third-party apps. So it's very easy to use. You go to Xcode, you define a code requirement, and you can basically assign it to your app. You can define a process constraint, a self constraint, a parent responsible constraint, and also library load constraints, where you can define which third-party plugins you accept. This is very well documented on Apple website. I suck at developing anything, and even I could use it. So it's really easy. But XPC protection. So this is an extract from Apple's WWDC 2023 Protect Your Mac App with Environment Constraints talk. They say, and talk about how you can use launch constraints to secure them, your apps. And they talk about XPC. Now, it sounds like launch constraints can make finally XPC secure. But if the XPC service is already running because your client connected to it, then launch constraints not in play anymore. So if it's up and running, then again, anyone can connect to it. And you still have to verify the connecting client on your XPC service. So we are back to square one. It doesn't solve anything, especially it doesn't make your XPC service secure. It maybe limits the time frame someone can exploit it, but it doesn't make it secure. But it gets worse. So I said, okay, let's still play with this. I want to try it. I made an XPC service running as root, set a responsible constraint that only my client application can start it. Then I wanted to connect to it, and I got a log message that the XPC service was crashed because of launch constraints violation. And I was like, why? I was playing around a bit, and okay, it's still crashing. There must be going on something here. So I launched a logger, an endpoint security logger, and checked out which is the responsible process identified by the system to launch the XPC service. And guess what? So it wasn't my client responsible, it turned out, which was weird. It turned out that launching the XPC service, the responsible process for that was the XPC service itself, which was like, this is bad in all levels. I actually submitted a feedback on this. So it doesn't even work. Like, even if you wanted to limit the connection, it just broken. And that is a lie. Apple, you had one job here. Securing Electron application. So again, the same extract from the talk. They tell about how POSIX spawn is bad because you can impact many of the environment the child process is launched. Now, typically, if you want to exploit an application when you launch it, the most dangerous items are environment variables and command line stuff. So Apple said there is a launch type 3, which means you cannot POSIX spawn a process. You have to launch it as application, okay? But, again, the most dangerous parts usually the environment variables and the command line arguments. Now, turns out that the open command will launch an application as an application, and the open command can pass environment variables and arguments. So we are back to square one. Or you can just use the API. I haven't actually tried this, but the open command uses this API. So like, yeah. Long yellow things. My other issues with Apple's WWDC talk. So they showcase like a command line helper tool that your application uses. Now, anyone really does it nowadays, and I'm not speaking about a command line utility you supply with your application for configuration, but an actual helper tool. Apple advises it, I think, for the past 10 years maybe, that you should use XPC for everything. Like for small functionality, or if you had a root daemon, you should use privileged helper tools with XPC and not command line helper tools. Like, this doesn't feel real world at all. Like, please show us an example, like a real XPC service, but I know you can't because it's broken. So library load constraints, I think this is actually promising. The big issue that if you want to use it, you actually have to know the team IDs of all of the developers who develop plugin for your application, and I'm not sure how realistic that is. So conclusion. Launch constraints for Apple binaries, I think that's great. So no doubt there. For third parties, there is a potential. Maybe they will improve it, change some stuff. But currently, it doesn't really mitigate anything. It does limit, so maybe it does mitigate in some corner cases, but in general, I think it doesn't. It only limits maybe your time frame when you can exploit something, or or limit your scope, but it really doesn't make your apps secure. I would say start to use it. It's pretty easy, and well, once Apple fixes the other stuff, and hopefully it will be better later on. Thank you.